All right, looks like I see we've gone live on my end.
Well, okay.
All right, I think we're good to go. So thank you everybody for coming to the 2021 Virtual Christmas Summit brought to you by Buscoyo Studio. So today's presentation by Keith Wesley is going to be about xLights coding shaders and shaders source code and how that's all used in xLights. And Keith would like this to be an interactive presentation, so feel free to ask questions, provide input as he goes along. Otherwise, please keep your microphones muted and video off, but yeah, feel free to ask questions. And if you feel like it, go ahead and put your questions in chat or any discussion, but Keith is probably not going to be able to watch the chat, so pipe up, pipe up. All right, so again, this is brought to you by Keith Wesley, and take it away, Keith.
Thank you. All right, let's see if we can share this screen. Okay, everyone should have that now.
We see it.
Get rid of that. Okay, so I get two things today. One is we're going to delve into shader code, which means we're going to go and look at some alternate websites which have shaders, and we're going to look at how you might go around taking one of those shaders that don't work with xLights and convert it across so that it does work with xLights, potentially change the shader somewhat so that it's more effective on the very low resolution props that we tend to put them onto. So we'll do a bit of that. And I'll also try to reserve, I don't know, half an hour or so, and we will spend some time going through the xLights code base, and I'll introduce you to the structure of the xLights repository, a little bit of the code so you can begin to orientate yourself around it. It won't be a full-on introduction to getting a build environment up or anything else. That sort of stuff will have to wait for another Zoom room time. But we'll do enough to sort of at least point you in the right direction. And maybe if you've been tinkering, maybe it will help you orientate yourself. But let's start with shaders. And the challenge with shaders is you can spend a hell of a lot of time playing with shaders. It can become something that you spend literally hours and hours on as you try to get certain shaders to work. And most shaders, but not all shaders, can be ported across to work with xLights. The ISF website, which is the format that xLights is largely compatible with, is fairly easy to bring in, and a number of people have done videos where they've taken shaders from the ISF website and downloaded them and managed to get them running in xLights with very little change. We're going to be a little bit more adventurous. We're going to explore some other shader websites which aren't as easy to bring in, but give you an idea about it and teach you a little bit about how to configure them and change them, because some of those aren't inherently possible. The shader format that we use is defined by the ISF website, and there's a couple of links here. Most of them are chopped off, or some of them are chopped off. We'll orientate it. And I would encourage you to take a little bit of look at, particularly at this, this ISF spec, which I think it's not that one. I have so many documents open here. This spec here, which talks through the ISF format. It talks about a number of constants that are defined, and not all of this is true in xLights, but a large amount of it is true in xLights. xLights doesn't support things like multiple pass shaders, and it's got some limitations on the bringing in of images and audio and the like. And you don't need to read this right now, but we will come back to this. But this is a bit of a reference document that you may want to look at some point as you get more into it to understand a little bit more about the format. The ISF website also has some broader documentation here. It does particularly talk about this header block here, which we will talk about in more detail, because this is how the parameterization of the shaders is done in xLights, and this is the format that is defined by the shader document format. if you want to get into, there's really two levels of shader development. One is you grab a shader from one of the websites that publishes shaders and you can play with them. The other level is to start writing shaders from scratch or beginning an understanding of how to code shaders. We're not going to do the latter. It's a little bit beyond me. There's a lot of math in shaders, a lot of matrix math, etc., which is all just a little bit beyond where I was at. It's also quite a different way to program. It's the way a shader program runs is not exactly like a normal program. Most programming is quite procedural. You break the problem down into a series of steps. You go through those steps. A shader doesn't run that way. A shader runs once for each pixel on the screen. And consequently, you've got to think about things very, very differently. And that's not something I necessarily am able to wrap my head around well. But fortunately, to do what we're going to do today, you don't have to be an expert in that. But if you watch some of these YouTube channels here, you may start to get an understanding of how they work. And you may at least be more comfortable with changing the shaders that you find, or potentially even get to the point where you can write your own. So yeah. But there is translation required as you go from the various formats. Now, some of the websites that you can go out there and find shaders, obviously, we can get rid of that one, we can get rid of that one. This is the ISF website. This is part of it, the way my screen's orientated here, only seeing part of it. But this is the ISF website. There are literally hundreds of shaders here. You'll recognize some of these as being in xLights today. They are in xLights today. They're just literally xLights just downloads them from this website. They don't necessarily require a great deal of conversion. Like I said, a couple of them won't work, but the vast majority of them probably will work just as is unchanged in xLights. So that's not that interesting. So we're going to skip past those. This is a website called Shader Toy. Shader Toy has a large number of shaders. It has about 49,000 shaders according to their website. There's a lot of shaders on here that will never work with xLights. They're heavily dependent upon images and things that xLights just doesn't have the capability to bring in. But there's still a lot of shaders here that will be brought across. It's a very popular platform for people to develop and share shaders on. And so you may want to look at this website as a potential source of shaders, and we'll talk a little bit about that. Shader Frog is another one. Shader Frog, you have to sign up to access the source code of the shaders. It has a number of shaders on there that would potentially look quite interesting in xLights. Not every shader can come across. There's a bit of combinational type work of shaders in Shader Frog, which is not supported. And there's a couple of weird things in Shader Frog. I'm not super keen on it. But yeah, you could absolutely take some of the shaders here and bring them across into xLights if you want. And then there's GLSL Sandbox. .com, which is where we're probably going to source our shader from today. This is quite a basic website. It's not necessarily easy to browse. It doesn't categorize things, etc. But it does have a lot of shaders, and a lot of them are going to be quite suitable to xLights. And so we're going to pick one up from here, I think, at least, and convert it and play with it. In fact, this is probably the one we will do, at least initially, and I'll resize my screen here in a second and we'll do it. Now, let me go through the presentation piece before we jump into that, and then we'll come back and we'll actually do some playing. Now, to convert a shader across to work with xLights, you need to do a number of different things, and you can play a lot with the shader first before you do all of this sort of stuff, but by the time we get there, you're going to have to do this to get it to work properly in xLights. And the first thing is you do need to put this header block on the top of the shader, which basically describes the shader to xLights. You know, you have the option to put the credit. Ideally, you would credit the original author of the shader if you're porting one across rather than trying to claim credit for it. You can also put in a description of the shader, which will appear within, it appears in a tooltip, I think, within xLights. And then there's a section here where we will end up parameterizing it. This is where you will define all of the configuration parameters that the end user will want to be able to play with the shader once it's in xLights. What you will find is the vast majority of shaders outside of outside of ISF are not well parameterized. Everything is quite constant. So you look at the shader and it's just like watching a video file. But you can often parameterize them, and we'll talk about how you do that. This is a shader. This is probably the most basic shader that you could write. It has a main function, which is called once per pixel on the screen. Fragment color is an output variable. It's a 4-parameter vector, which means it's just a value that has 4 components to it. And those components are a value between 0 and 1, and 0 being effectively off, and 1 being effectively fully on, and they represent the colors. So the first one is R, the second one is G, the third one is B, and the last one is the alpha channel. So red, green, blue, and transparency. And so this particular shader here, which we can write, will basically draw the screen red. That's all it does. And it's really as simple as that. And you notice that it has nothing in this about the number of pixels on the screen or anything, because it's run once per pixel. So every pixel runs this program and it comes back and says, set that pixel red. But obviously you want to get a lot more interesting than that. There are a number of variables or variables because they're passed into the shader each frame that renders. And these are going to be the key variables that differ across the various platforms that we need to align to what xLights is expecting so that xLights will work correctly with the shader. The first one, the ISF frag chord, that's a 2-dimensional vector that represents the location of the pixel that is being rendered. Now, it's an absolute number, and so people would typically convert that into a normalized coordinate of between 0 and 1. So 0, 0 is the bottom left-hand corner, and 1, 1 is the top right-hand corner, because most shaders work with those sorts of ranges. The render size variable is the actual size of the render buffer. Now in xLights, that tends to be a relatively small render buffer, because if you're putting it onto a matrix panel, it might be 48 by 16 or 24 or something. So it tends to be quite small. Whereas most of the shaders that you will see on the various websites are expecting to render on a screen that's 800 by 600 or 1200 by 700 and odd pixels, etc. So the smallness of the screens or the buffers that we render on in xLights can often be a challenge for the shaders. The time variable is the current time of the frame being rendered. And this is a key variable because when you see time referenced in a shader, the shader is going to be a shader that probably moves and animates. If there is no reference to time inside the shader, it's typically very static. And so if you see a static shader that just displays an image, but you want it to do things over time, you'll want to introduce the time variable into it somewhere to change color over time, or change position over time, or to change the way in which the screen is distorted, or whatever else over time. Time delta and frame index are much less common. Time delta represents the amount of time that elapses between each frame, which is going to be, in our case, typically 25 or 50 milliseconds. And the frame index is just the index of the frame. So the first frame is frame 0, then frame 1, and so forth. Again, these aren't really commonly referenced in the shader source that we'll look at, but if they are, you can access it and convert it. xLights also builds in a number of functions that you can access, and they're listed here on the next several screens. We're not going to go into them in any great detail. Most of these are used for sampling colors from another image, and so xLights has the ability for a shader to pick up the underlying layer underneath the shader and apply transformations to it. And so think of things like the warp effect and the kaleidoscope effect. You can do similar things with shaders, where the shader picks up the underlying layer and then transforms it in a certain way. And so you may end up using these functions as helper functions in that case. Some of these are also used to replace some functions that might exist in some other shaders, which xLights doesn't support. And so there's a bunch of these things defined here, and I'm not going to spend any great deal of time on it. In order to parameterize the shader and allow the end user to change the values that the shader sees, we need to be able to define variables. And there is a number of different variables, and these variables turn into sliders and combo boxes and checkboxes in the xLights user interface. And so the first one, and probably the most common one, is a floating point variable. It has a minimum and a maximum, a default, which is typically the default value. I typically use the value that the shader has on the website, but you may choose to actually change that default value to be something that's more likely to work on the types of resolutions that we use in xLights. The variable name is the name that particular parameter will be referenced by inside the source code, and the label is the name that the variable will have on the screen that the end user will interact with. And I would encourage you to make that a little bit more human understandable as to exactly what that particular variable does, rather than just use the variable name itself. These are floating point numbers. You'll find that shaders generally don't like integers. Most variables are floating point numbers. The shaders themselves do run on your video card and run using largely floating point values. The second variable type is the color. Now, the color is mapped to the xLights color panel. So the first color on the xLights color panel will be basically mapped in the order in which you put it in there. So you can have multiple of these parameters inside the JSON file that you then reference inside the shader, but they will be mapped to the color panel in xLights, allowing the user to choose which color the shader uses in certain scenarios. Most shaders don't use this. Most shaders generate their colors internally using mathematics. But they can pull at least some basis of the color from xLights if you wanted to, and you would use one of these color variables to do that. As I said before, the values are defined in the range 0 to 1, not 0 to 255. So you have to get used to that.
Keith, how many colors can we pull from xLights? There's the 8 on the color panel that you can tick off, but you also have that hue bit at the bottom. So is it the 8 or the 9?
Yeah, the hue is applied after the shader renders. The hue is applied to all colors in the effect. So the 8 colors are drawn from xLights. The shader is rendered, and then the hue shift is applied onto the shader after it's rendered.
Okay, thank you.
Point 2D, so some shaders you will see references to a mouse, and if you will use them on the various shader websites, you'll find that you can interact with the shader by either just dragging the mouse across the shader, or sometimes you need to point and click at the shader, and the shader will distort in some way or react to the mouse in some way. These are typically represented as these point 2Ds. In xLights, it will be represented as an X and a Y slider, which you can then put a value curve on if you want to. But that's how these are typically represented. We don't have a simple way to represent the mouse in an xLights render. Audio FFT will pass in the audio frequency spectrum breakdown of the audio, and so you can have shaders which are audio sensitive. Some shaders expect the audio FFT, some shaders expect the audio. As Tony was discussing earlier, the audio ones aren't supported in xLights at this time. I definitely think we should, it hasn't been implemented. Booleans, if a shader calls on a Boolean parameter, this will be displayed as a checkbox to the user, and this allows the user to turn an option on or off within the shader. Long variables, these are less common, but you can have, basically this is a combo box. So if you're going to have a number of different absolute values that you want the user to be able to set, you can represent those using these long values, and they're displayed inside a combo box where the user chooses one of the values. This is not like an integer parameter where you can define any number. You typically use a float for one of those. This is used for a limited set of possible values. And an event. These are very uncommon. I think Tony mentioned this the other day. The only place he's seen this used was in the lightning shader in xLights. This enables you to effectively, you trigger an event in the shader and it's picked up in the shader, and the shader does something when that event occurs. And those events are tied to a timing track inside xLights. And so whenever that timing track has a timing mark, the event will be sent to the shader, and the shader will do whatever it is that the shader does in that scenario. And then we have the image parameter, and the image parameter is how you access the underlying layer underneath the shader. Shaders that use the image parameter will typically have their canvas mode turned on, which gives them access to that underlying layer data from the shader. And that's it. Then there's a couple of things here, which is some of the conversion parameters, and we're going to reference these as we dive into a shader in just a minute. And so if you ever see a reference to something like a texture 2D function, you'll probably want to replace it with this function here. And we'll come back to this, and then a texture 2D rectangle where you replace it with this function here. When you choose a shader, you want to choose a shader that has large blocks of color. You don't want a huge amount of fine detail unless it's possible to zoom in on the shader. And the reason for that is things which have lots of fine detail don't generally look good in xLights. xLights, just due to the lack of resolution, just those sorts of things don't look good. And obviously movement. Generally, you want to have some sort of movement in the shader that you're bringing in, or at least be comfortable adding the movement to the shader. The only time that a shader with no movement, I can't think of a reason why you'd use a shader if you've got no movement. You may as well, at that point, just put it into an image file and use it in xLights as an image. Converting the shaders, and we're going to go and do this in a minute. Use the online sites. Definitely explore the constants inside the shader, and we'll do a bit of this where you want to understand what each constant is doing to work out which constants are interesting. You'll want to get familiar with the xLights log file, because when xLights is using your shader, if there are any errors around using the shader, all of the errors are placed into the log file. And so you want to go into the log file and look at the log file to understand why the shader is not working. It also lets you see how xLights manipulates your shader to compile it. And so you can see a little bit behind the curtain as to what xLights is doing. Definitely concentrate on getting it to work first before you spend a great deal of time customizing and configuring it. You don't want to invest a huge amount of time in a shader only to find out later that it will never work in xLights, because it depends upon something that xLights doesn't support. And once you've got that working, then you can start exploring adding the JSON and getting the inputs, etc. Making sure that all the variables are renamed, and rename the main function and all of that sort of stuff, and then introduce the variables. And we'll do all of that in a minute. A couple of websites that you might want to look at: GLSL Shadebox, Shader Toy, and Shader Frog, along with the ISF website. Explore and see if you can find things. And this is a bit of a cheat sheet for people that are doing the conversion. The parameters that we talked about, so we talked about the time parameter in xLights, which ISF also uses, but you'll see that on the other websites, it's got a slightly different name. We are going to need to address this. And so this is a table that you will probably want to come back to at some point, grab a screenshot of it out of the video or something, because you'll want to access it. The render size is the size of the screen. Again, it's got slightly different names in the other shaders. The fragment coordinate is the coordinate of the pixel that's being rendered. Again, different names. The normalized coordinate is the same thing, except it's a value between 0 and 1. We talked about the time delta and the fragment index. I didn't necessarily find parameters. It doesn't mean that these shaders over here don't support those parameters. Just in my research, I didn't come across one, so I didn't note its name. And fragment color is the output color of the pixel. And again, this has slightly different names on each of the platforms, and we will need to rename these things. And some of them have mouse support, and this I channel 0 to 3 on Shader Toy is how it accesses underlying images and the like, which we don't. We use the parameters in xLights. And I think that was all I had as a presentation. So let's go in, and we are going to, in our discussion, I'm going to resize this so that you can see the whole thing. We're going to play with this shader here and try to bring this shader into xLights. Now, Tony quite generously has already verified that it works in xLights, so we won't do that. So what we are going to do, however, is it's interesting. There's another interesting website there. I wonder whether this website's got more shaders on it as well. All right, so what we're going to do is we're going to play with this a little before we start bringing it into xLights. So the first thing I'd like to do is understand how can we change this thing, and what do all of these things here do? So we can see from the top here that this is accessing the resolution and the time. So that tells us the resolution is the screen size and the time is the animation, which is why it's moving. If I was to find the time variable in here, what's the time variable? Oops, a little bit further, it goes further. There it is, there's the time variable there. So if I was to take that time variable and make that a 1, it doesn't like integers, it likes constants. Okay, that didn't stop the movement. Where else is there a time variable here? Okay, there's a time variable here. If I was to make that 1.0, did it stop moving? It did not. References the time variable a lot. All right, well, let's not worry about that. There's actually quite a lot to this shader. Okay, so let's clean this thing up a little bit. Let's get rid of all these comments because they don't do anything. And so they're just cluttering up the code that we're looking at. This here is setting the color. And so playing with the parameter. Now, the way I like to experiment with playing with the parameters is typically change the order of magnitude. So if I was to, let's change this by 2 orders of magnitude, you can see that the shader has become a lot more grainy rather than smooth. So that's probably not a parameter that's particularly useful to change. This one here, similarly, it made it a lot more grainy. Again, probably not something that's useful to change. Let's try changing this. Okay, that made it a lot dimmer. Again, maybe not something that I want to spend a great deal of time changing. Let's come up to these ones here, this beam direction. All right, what happens if we make that 0.9? Okay, well, that's interesting. It kind of moved it across a little bit. What if I make that 1? What does that do? That didn't do anything interesting. The time here is probably going to change the speed in some way. So if I set that to 1.2, again, it's not making a huge amount of difference. We are not seeing a lot of difference here. Sometimes you might want to actually multiply the whole thing. Like this shader is very resilient to change. All right, let's go up here. Let's change. Oh, that made a difference. In fact, that made it a lot more colorful potentially. Let's go extreme. Well, that's not so good. Let's go to 5. Also not great. So I don't know. I think this one here might be a parameter that's interesting, right? So this is, as we go up to 0.9, the colors become a bit deeper, right? I don't know. Let's call this color depth. So what we're going to do is we're going to come up to the top here, and we're going to say const float color depth is equal to 0.5. All right, so we're just going to move that up as a parameter because we're going to come back later and play with that. All right, so here we've got some more constants. Didn't do anything interesting. Let's change this, make this 116. Yeah, it's not that interesting. 110. Not that interesting. Why is this 8? What's that going to do? Not a lot. All right, now we got position. So positions often are interesting, but this one's not. Whoa, that changed the speed pretty dramatically, didn't it? So let's call this thing speed. Const float bucket type speed. All right, so that's the speed. Where were we? Color depth. We were here, speed. All right, let's try this one here. I don't think that was that convincing. Not that interesting. Okay.
Actually, maybe it makes it rotate a bit more, it seems like.
Oh, did it? Oh, yeah, so it did. Sorry, okay. Let's call it rotation. Thank you. I was beginning to wonder if everyone had left me.
We're all captivated here.
Are you? I'm sure you're not.
There's a few of those things that you changed that, wow, that does look cool. I found it just cool that you could just come in here and change some things around and see it right away. Yeah.
Yeah. Well, this is the advantage of playing with them online here is you can see which things are going to make a difference. Now this value here, I don't think this was not making any difference, was it? We've already played with the rotation. I think we'll move on. Let's have a look at this one here. What happens with this one?
Just one thing I'm noticing is it's a lot easier to work with the shader here in its raw form than to port it into the ISF and then try there, because in ISF you have to re-upload every time you make a change.
All right. So this is definitely doing something. No, this is moving the line away, isn't it? So I actually think this one here is quite interesting. If I change it to 1, yeah. So I'm going to call this position, if I could spell. Pause. Why am I putting 2 S's in position? Okay. We at some point here we're going to just stop this, because obviously every constant is potentially a parameter. So we'll leave it there for now. You can come back and play with this later if you'd like to add even more. All right. So we've played a little bit with the shader. We found some parameters which maybe we don't want to be constant. We would actually like the user to be able to play with. So let's now start to prepare this shader for xLights. And so the first thing that we need to do is take a copy of that code, and we need to go to something like a Notepad++, and we need to paste the code into Notepad++. Here it is here. And we will want to save it somewhere. So, oh, this will do here. We'll put it here. This is fragment shader, FS, because that's what xLights likes them to be called. Now we can start to prepare the shader for xLights. And so let's try in the first instance to do the minimum amount of change necessary to get it into xLights. And so there's a couple of things that we need to do. The first thing we need to do is to go and grab from our presentation here, that header, this header here that we need to put at the top of each shader. And so we're going to do that. We will, whoops, where am I? I'm all over the place. Shaders, left, right, and center. This is the one we're playing with. Actually, it was in the code. What am I doing? It's down here. All right, we'll give credit to the original shader author up here, because we didn't write it. And I don't know, we're calling this file line or something, weren't we? This is the name we wanted to call it. Now we're going to get rid of this hash define thing here. That's not required in xLights. And we're going to the resolution. Now the easiest way to deal with these resolution and time variables is to use a hash define. And so what this is like a global search and replace. So everywhere that you find time, we're going to replace it with time, and everywhere that you find resolution, we're going to replace it with render size, because that's what xLights expects them to be called. And we can get rid of those now. And with any luck, that's the only change that we need to do. The main function looks fine. Some main functions on some of the sites will have extra parameters in here that we would need to remove. Oh, we will need to deal with the glfrag chord. So again, let's do a hash define for that as well. And does anyone remember what we needed to call it in xLights? Where's our
You were using ISF, but xLights accepts the glfrag chord as well.
Yeah, I think you're right. I think behind the scenes we deal with that.
And the same with the frag norm chord and frag color.
Right. But we can change these. Let's for the hell of it change them, because we can do this. So we can change that to be that. And actually, maybe we can't. All right, we'll leave them as they are. All right, let's leave it like that. Let's save that shader. And let's go to xLights. And let's see what sort of layout have I got here. I've got a reasonable size grid, 50 by 16. Let's up that a little bit. Let's make it 100 by 50 just to get a bit of density. We'll save that. We'll create a new sequence. Let's grab our shader, bring it down. We'll browse and we will grab our shader, which is not in that folder, but in that folder. There it is there. Oh, what do you know? It worked first time. What are the odds? Doesn't quite look the same, does it? But that's okay. All right, so our shader came in first time. Let's break our shader just because I want you to see what happens, and you can't see it unless it breaks. So when it breaks, it comes up in yellow. And if you go and do a tools view log, and if you go to the end of the log file, you can see that it's got this error, failed to compile the shader program, and immediately prior to it is a full copy of the shader program that it was trying to compile. And most of this looks exactly like the code that you imported. The difference is at the top, there's all these extra functions that have been added. So those functions that xLights introduced. And there's a whole bunch of variables here that have been defined, which is how xLights passes all of those values in. But even more important above that is the error code that the compiler failed on. And so it's telling us that on line 84, there was these DD characters that it didn't understand. And if we go back here, it turns out that line 84 is actually line 22, and we can save those. Now, if the shader compiles without error, there won't be anything in the log. So sometimes you just need to force it to error so you can go and see what's going on in the log file. But there's no parameters, right? Everything is constant. Despite all of that playing around we did with those parameters, nothing has actually appeared here. And the reason for that is we haven't told xLights about those parameters yet. And so to do that, we need to go back to our parameters here, and all of the values happen to be floating values. And so we're going to grab a copy of this thing here. We're going to go back to our shader, and in the input section here, we need to add in our parameters like so. Now, this is a JSON format. For those of you familiar with JSON, it's a very, very common data format. And we identified 4 variables that we're going to introduce. So let's add them in here. We'll spell color right for the first time in xLights. We're going to call it color depth just as we did below. So that's the variable. The value that they suggested was 0.5. So we're going to go with 0.5. Now, we didn't really test the total limits of this. So here's where you need to say to xLights, how much of a range of values do you want to support? We should probably go back to the shader website and experiment to see what range of values makes a difference so that we can work out what a good minimum and a maximum is. And we won't do this for all of them, but let's quickly go back to this, and we're looking at the color depth. So if I set this to 0, does it produce anything sensible? Yeah, it's not great, but it works. If I set this to 10, is that sensible? That's not really sensible, right? If I set it to 1, is that sensible? Yeah, that's not so bad. But it looks like once I get above 1, the whiteness starts to appear. So maybe between 0 and 1 is the right value range for this. So we'll set the maximum here to be 1. We can then copy this and add another one. Don't forget to put a comma after the first one. This is a list, and so you need to comma separate them. and we go down to our next one. So our next one is speed. Its name is speed. It's a floating point value. The default value is 32.0. You do need the point zeros. It needs the floating point. So let's have a quick look at our speed. Our speed. So what's a speed of 0 do? Well, it still does something. What's a speed of 100 do? So 0 to 100 looks fine. What's minus 100 do? Oh, it goes the other way. So maybe we want to be able to support both. So shall we do minus 100 to 100? Minus 100 is our minimum and maximum's 100. Okay, let's go and add our next one. We've got 2 more. Let's just add. Okay, so the next one, what was the next one? Rotation. Floating point value. Let's go back to it quickly. Rotation. Okay, so a rotation of 0, what's that do? Still rotates. Rotation of 100, what's that do? Whoa. That's a bit much, don't you think? 50 maybe?
That's more like speed of rotation rather than rotation.
Yeah, I know it is, but that's okay. 50 looks, oh, that's interesting. And 0. So we're going 0 to 50. I think that'll do. Oh, rotation up here, sorry. So we're going from 0 and we're going to max this one out at 50. And the last one is position. Floating point number. This one's got a value of 2. And our position of 0 was nowhere, right? Sometimes it doesn't like zeros. Sometimes it isn't, doesn't. Okay. Ooh. Not sure even 1 is great. You probably want it on the screen. Well, 5's a bit much. Maybe 1.1. I think 1.1 might be our minimum. What's 100 do? Even that's not bad, is it?
Looked like it took it diagonally across the screen.
50's no different. So there's no need to go as high as that. 30's no different either. So we're starting at 0.1. What's 10 do? Might want to go a little bit higher than that. Maybe to there. Maybe we'll go from 0.1 to 20. 0.1 to 20. And we're done. So we'll save that. We'll go back to xLights. We'll click on the effect. Okay. Didn't like that. What did we do wrong? Everything's a floating point number. Oh, I know what we did wrong. We've effectively double defined these things now. So we have to take those constants out. Now we'll click on it. Okay, so the thing's back, but we don't have any parameters. You might need to click off it. Sometimes you, and I think Tony showed this the other day, sometimes if you browse to another shader of something other, some other type, and then come back, it will reload the parameters. Okay, so our parameters have now reloaded. It's just a matter of getting xLights into the mood to load the parameters. And so all of our parameters are there, our color depth is doing what it does. Our speed, our rotation, and our position. Yeah, our position's working as you would expect. So I don't know, that's a great shader. We definitely need to maybe potentially find a zoom or etc. But that's essentially how you go about converting a shader from a non-compatible shader into a xLights compatible shader and parameterize it. Any questions? Have I motivated anyone to go? I cannot see chat. I can see chat's going off, but I can't see it. Oh, there it is.
Yeah, do you see chat now?
Yeah, they do all become air. Everything that's a floating point value becomes adds a value curve, so you can change it over time as well.
Okay. I know there is a website that converts shader toy to ISF. Is there any chance that there would be a shader toy / ISF to xLights website?
Well, there already is from an ISF perspective. So xLights has already been written and there's a bunch of substitutions that go on the background to try and make the ISF ones work automatically in xLights. What we haven't done is gone and tried to make shader toys work automatically in xLights. The challenge you run into is we'd have to know what format it was in to start with, because I can't just go and replace every time variable with a time variable from xLights, because what happens if it was written and used the time variable, because on the ISF website, the time variable doesn't exist. So you can quite happily use it within your shader. So you actually kind of need to know what format it's in. We chose to use the ISF format because the ISF format had all of that nice parameter description logic. And that's obviously something that we wanted in xLights because we wanted the effects to be parameterized. If the effects weren't parameterized, you may as well just turn them into movie files and do it there.
Awesome, thank you.
Right. What's this? Brent asks, can you use the ISF editor to download the shader and edit the variables for xLights? Yes, absolutely you can. I did it in the GLSL shader location because you can do it in real time and you guys can see how you work out what's happening. Everything that I did on the GLSL shader website, you could in theory have done in the text editor and just kept going back in and out of xLights to work out what was happening. It just takes a bit longer, and you've got to keep diving into log files to see why things fail. Whereas on the website, it's very quick to do, which is why I tend to do it there when I have to. All right, I'm conscious of the time. I think I just have just over half an hour to touch on the xLights source code, right?
Yep, that's what I'm showing.
Okay, good. Okay, so let's look at xLights. All right. So the xLights source code, when you download it onto your machine, goes into a folder called xLights. You will need to download and install the WX widgets framework, and it should sit in the same level as the xLights folder, because the xLights folder or the xLights code expects the WX widgets folder to be here. This is the only thing other than the xLights repository that you need to download. It's just too large to include inside the xLights repository, so it's not included. Everything else that you need, including all of the other libraries that xLights depends upon, are included inside the xLights repository other than the WX widgets. If you are going to set up a build environment, you should choose the appropriate build environment document, whether it's OS X or Linux or Windows, and open this document up and read it very, very, very carefully. If you're doing Windows, which is the platform that I use, you will want to go down to, I use the Visual Studio instructions. The MinGW instructions, we don't use anymore. The production release of xLights used to be built using the GCC compiler and the MinGW environment. We moved across to Visual Studio after we started encountering a number of issues mid to late last year, or maybe it was mid to late the year before. And so everything's now been moved across to Visual Studio. Visual Studio, like the GCC environment, there is a community edition of Visual Studio. xLights is built using that. You don't need to go and buy yourself a Visual Studio license, etc. But you do need to follow these instructions very carefully. There are a number of changes that you need to make to things in order to get things to work. You don't necessarily need to do the Windows installer piece if you're not building xLights for release, but this is used for building the actual release packages. But follow those instructions really, really carefully. You may want to install code blocks if you want to make changes to the xLights user interface. That's not actually done in Visual Studio. And while it's tempting to make UI changes in the code itself, I would suggest you don't do that because any of your changes will be rejected. You need to make UI changes inside the code blocks development platform because they have a tool in there called WXSmith. And the WXSmith toolset maintains all of the UI code. And so if you directly manipulate the UI code and don't change it inside WXSmith, the next time someone touches that source file in WXSmith, all of your changes will be obliterated. And so that's not great. WXSmith is an absolutely diabolical piece of software. It's extremely, it works, and it's just, it takes a while to get your head around, particularly when it comes to things like the sizes and everything. That's not a great example. Here's the DMX panel. And so all of these red boxes, etc., are sizes that allow things to dynamically size. And you'll see sometimes in xLights that some of these things don't work right. And that's typically because even after using these tools for 5 years, I still can't make head or tails of it at times in certain scenarios. It just seems to have a mind of its own. But yeah, all UI changes are done in here rather than done in the source code or in Visual Studio. Let's get out of there. Let's go to Visual Studio. Actually, no, let's go back to the file system. So let's talk to a couple other things that are in here. Let's do a quick run through of some of the key folders here. The bin folders are where things are generally built to. Some of the things which are packaged in the final release also are maintained here. So all of the logging properties files, so these are these properties files here configure the logging in xLights. So this, well, it's the xschedule one, but there's an xLights one here somewhere, this one here, which is the file that gets distributed to the user when they install it. Here are the dictionaries for the phonemes, which are packaged, etc. These are all the pre-built DLLs that are used in the release version of xLights and so forth. The build scripts folder, these days it just contains the Microsoft Windows one. So there are script files here for building xLights. This is how we actually build the release versions that go out. These ISS files are the setup configurations. The only one that changes regularly is this common file, which is where the version number is updated. And then I just double click on the command file and it goes off and it builds all of xLights, packages it up into the file that gets uploaded onto the website, which is the release version when that needs to happen. And the output folder is where the actual releases get built into before they get uploaded to the website. So that's the build scripts folder. The color curves folder, these are the prepackaged color curves which are included in xLights. So look, if you wanted to come up with a new set of color palettes color curves or color palettes that you'd like to see included in xLights. These are, this is the color curves folder, here's the palettes folder, and here's the value curves folder that would then get included in the xLights build. In the root folder, there is actually a document for those people interested called dependencies.txt. This goes through and just lists out all of the other open source projects or other things that we have got dependencies on. You don't necessarily need to do anything with this, but if you've ever wanted to understand, the Z standard library that's used for zipping up the internals of the FSCQ file, which is the format that the FPP prefers, is supported by this library here. It happens to be a Facebook library that's open source. The WXLED library is used for some UI elements and so forth. So all of those things are all documented in that file there. Sorry, where was I? Controllers. Controllers is where the descriptions of the capabilities of all of your controllers are stored. So if you ever wanted to know how the visualizer or the upload of controller configuration validates that the way you've configured things in xLights is correct, it's all done using these files here. And so, if you were to go into the Falcon here, for instance, and it's the structure is not incredibly obvious, but there's effectively a hierarchy of settings. And so, the Falcon controller supports upload. It allows you to upload inputs only. It supports multiple simultaneous output protocols and multiple simultaneous input protocols. So everything doesn't have to be a single protocol. Universes, however, must be in numerical order because some of the Falcon versions sort the universes. It supports virtual strings. It supports auto layout. It requires or wants us to merge consecutive virtual strings. So if we were to remove this setting here, the Falcon would no longer merge all your virtual strings together when it did the upload. So things like that. It lists the pixel protocols that it supports and so forth. Right, so there's a whole bunch of these settings here, and there's a class inside xLights that deals with all of this sort of stuff. But yeah, if you're a controller vendor and you would like your controller better supported, you can play with the appropriate xcontroller file here, or submit a pull request and ask us to update some capabilities if we got things wrong. So yeah.
Do you have
yeah, I got
up
that.
there?
You can't find WX widgets as a sibling folder in the xLights folder. That's right. You need to download it. You have to actually go to the WX widgets GitHub repository and download it. We don't include it because of its size. The download folder is interesting. So if you wanted to add shaders to the shader download, there is this shaders.xml file which needs to be updated. So all of the shaders that you can download in xLights are listed in this XML document here. And Tony has been submitting pull requests to update that document to add additional shaders. So if you want to do that, you can. The rest of the files exist here, but they're not generally referenced here. But
You with us, Keith?
I think he just froze.
Oh, we were going so well.
There he's back.
Probably
now.
fell asleep.
No, you can fall asleep.
Maybe a shark cut the fiber between here and Australia.
You'll hear me, Ryan.
Baby shark? No, never mind.
He didn't get the fibre.
Hopefully he's not talking away like
He
something
probably,
happened yesterday.
he probably is. He probably hasn't realised.
Yeah, he hadn't realized it. His connection back to the U.S. has not stopped.
It's probably his internet. I don't know where he lives, so
Yeah, he's
He's
in
gone.
Sydney area. All right, he dropped off, but we'll see.
That's
if
good
we can
news.
get
He'll
him.
know. He'll jump back on.
Yep.
Yeah,
Yeah.
he'll pick up that he's dropped.
Let's see that. I'm going back on mute. Be quiet.
I thought it was me for a minute. I thought I was going to lose him again.
All right, we'll put in a little filler there, and hopefully we'll be able to get him back here shortly. Sorry, folks. And I will not be able to jump in and add anything if Salt's still here. You know, you better be getting ready. Yeah.
I'm here. I was just updating a couple of my notes. I don't know if anyone would be interested in them, but it's a
Got my
few things.
back?
Here you are. You're back. Yep.
Welcome back, Keith.
Good.
My internet dropped out.
It was so stable there.
Where were we?
You just went through the repositories for
The controller upload. I know we just did that. And
Yep.
All
All right. Which do you have my screen? Which screen do you have?
looks like we got your file explorer.
Oh, good. Okay, that's what I wanted. All right. Okay. So yeah, we've done controllers. I was talking about download. So this folder here is where it lists the XML documents. Some of these are accessed directly by xLights. So when you try and do a shader download, it actually accesses this shader file. And this can be maintained by anyone. You can issue a pull request if you want to add a shader to the xLights download. And when it gets included, xLights everywhere immediately will start to pick that shader up from there. Some of the other files are not accessed here directly. They're maintained here, but they're copied to the xlights.org website and referred to there because for other reasons. So things like the faces, for instance, the face content is absolutely huge. It's hosted on the xlights.org website, but the index document is maintained here behind the scenes. The images folder is a bunch of images. The only thing to realize in xLights is images need to be converted into a format called XPM. GIMP is the editor that I use whenever I need to touch an image in this format. They're actually text files, which are then hash included into xLights. But you can actually edit them in GIMP if you want to, but then you've got to go and basically butcher them because GIMP changes some of the headers up here and that they need to be changed back. So they're a bit of a pain to work with. Images in general in xLights are a pain to work with because of the development tools. The lib folder is just a bunch of library files, which is where most of the third-party software is actually maintained. It's either statically or dynamically linked in, it depends. Where else is it? Then you've got the actual source code folders. And so each of the key elements of xLights has got its own folders. They do reference each other. xLights references some things in xschedule and xschedule references some things in xLights. So for instance, all of the output processes in this folder here, which is all of the different types of outputs that xLights can produce to different protocols, all of those things are maintained in the xLights folder, but xschedule uses them. If I add a new protocol, like we did last year, we added the Kynet protocol to xLights. When I added the Kynet protocol, it got added in here, but xschedule immediately inherited the capability to output the Kynet protocol because it was because they reference each other. The other key folders here, if I can go through them, I'll just touch on the ones that have got interesting things in them. So the controllers folder contains all of the controller specific code. So if you want to see the HinksPix code, it's in the HinksPix folders. The Falcon stuff's here, the FPP stuff is here, SAN devices and so forth. All of that sort of stuff is contained in.
Did we lose them again?
Sounds like it.
Yeah,
controls.
looks like he's dropped again.
Oh no, he's coming back.
Am I back? Oh,
Yeah, you're back.
You did
Oh,
drop.
there he is.
okay. This is not good. Sorry, I was saying the effects are all located in the effects folder. So here, every effect has an effect file, but also a panel file for the UI for the effect. So all of those are in there. The models folder contains all of the various models in xLights. If you were a new person to xLights, I suggest you stay away from the models. They can be difficult to work with. Starting with effects is definitely a much better place to start your first couple of changes. The outputs, like I said, contains all of the protocol outputs that xLights can produce. The preferences panel is all maintained here. The sequencer maintains most of the effects grid type stuff, the elements, etc. And that's about it. Everything else just sits in the raw xLights folder, which is absolutely huge. There is a lot of code in here, a lot of code. The style in xLights is not consistent. It's developed over time. It's been influenced by different developers with different opinions about what things would look like. Generally speaking, we try to remain consistent to the developer that was in there in the past. Unless you're going to entirely bring it into line with some other elements, you generally just leave the style the way it is, and we just accept that that's how things are. Things are generally, so everything is written in C++. There's very little anything else in xLights. It's all, you know, some parts of the code are really, really clean. The design's very consistent. So, you know, things like the output processing was, you know, I've reworked that a couple of times. It's all very consistent across all of the files. Everything, you know, it's got strong use of inheritance where it makes sense. It's got very consistent structure in the files. It's all very, very clean. The effects are generally mostly pretty good. There's a couple of effects which could do with a bit more of a cleanup, but generally speaking, the structure of the effects is all very consistent. The models is a bit of a nightmare. And the way in which we manage the models is just horrific and desperately needs a bunch of rework. So, you know, there are some things, and that's why the layout tab at times can be a little brittle just because of the way in which things are processed. But let's dive in quickly to some of the effects. Let's do something that's maybe not too all over the place. I won't do the shader effect because there's a lot of extra crap in the shader effect. But let's do something really simple for starters. Let's do something like the on effect. So the on effect here, it's very simple. You know, this is including the icon for the on effect. The way in which settings are maintained in xLights is using strings like these. So every control on the panel has a name. So if I go to this, so this is the UI for the on panel, which is quite simple. Most of this code is generated. It's in fact, the only code in this file here that's not generated is these few lines here. Everything else is generated by the WX, by WX Smith. the controller, the parameter settings have been given a name. And so these names here are the names of the settings, and these are then referred to in, they're slightly morphed, so they will typically have the ID will be chopped off and an E will be added to the front, but that will be the name of the parameter that the effect will then go and access. Over time, some things have changed, and so sometimes you'll see there's conversion code, etc. This sets the default parameters. So this is where when you reset the on effect to its default parameters, this is where that's set. Getting the effect string, the way in which settings for an effect are stored is they're stored in a list of parameter values. And if you've ever opened up a sequence and looked at how things are stored, they're stored as a string of parameters. And you can see here those settings and how they're saved inside those settings files. Value curves always have, so it's always E for effect, the type of the parameter. So this is a value curve parameter. This is a text control parameter. You'll see sliders occasionally, checkboxes and so forth. And then this is the name of the parameter that's being saved. So that's typically how things are stored. This here does the color background on the effect. This draws the color background, which generally is not done. And then this is the actual render. So this is the function that does the render. So you'd think the on effect would be quite simple. It's actually not. There's a reasonable amount to it, and that's because of all of the options. This here is grabbing all of the values for the settings. It's passed in as a map of settings, which is essentially an indexed list of settings, like a map, and it will grab all of those. Nothing here has a value curve. Is anything? There is a value curve. So here's a setting that is retrieved from a value curve. So the transparency is the only value curve parameter here, and that's how that's retrieved. So these things are all very standardized. You go to any effect and you look at a parameter that has a value curve, and it'll have something like this in it. The rest of the complexity here is largely down to dealing with all of the parameters and the various options that need to be displayed. So that is effect settings. What else is worth showing here before I move on? Yeah, key classes. So the audio manager does all the audio processing, including everything from loading the audio file, converting it to the fixed format that we use internally once it's loaded. It does all of the waveform parsing. It does all the fast Fourier transforms. Everything associated with audio is in the audio manager. Conversely, there's a video reader here that does all the video processing. So all of the video reading and conversion, etc., is all done in the video file. What else is kind of interesting? Render cache. So all of the render caching, all done by the render cache element. The pixel buffer class is pretty important. The pixel buffer class is the thing that deals with all of the rendered data. The way in which xLights works is when an effect is rendered, one of the parameters that is passed into the effect is, that's the panel, sorry, we'll go to the effect, is this pixel buffer, this render buffer. And this is generally black when it's passed in, unless canvas mode is turned on. If canvas mode is turned on, then the buffer will contain data. And effectively, the effect is just writing into the pixels inside this render buffer. The pixel buffer class is then responsible for taking those buffers and blending them all together. So in all the transitions that you might experience, like fades, etc., the blur is all contained within this class. So yeah, all the blurring, all of those various blend modes that you might see are all contained within the pixel buffer class. Trying to think of which other ones are the core ones. The file formats are all maintained in things like the XML file. So this is the sequence file class. So everything associated with storing a sequence is maintained in the xLights XML file. The RGB effects file, however, is not there. That's actually much more distributed. There's a number of different classes that process the RGB effects file for each different section of the file. All your mapping when you do an import is dealt with by this mapping. It actually deals with multiple formats. It's not just the xLights import. Many of them use different ones.
We're coming up to close to 10 minutes to the end of our time, just so you know.
All right. Before I hand over and sort of see if there are any questions, which there often aren't, there are also the other projects. So xSchedule's the other one that's significant. It has playlists. The playlist folder contains all of the various playlist items that are supported. So all of the different things that you can schedule in the playlist are in there. All of the events are in here. So all the things that xSchedule can react to are contained in the events folder. The other thing that's interesting is there are plugins. So the demo plugin, which is a C# shell plugin that you could customize if you wanted to create a plugin, is there. The Remote Falcon plugin is there. This is the SMS plugin. They're all contained in folders there. So I know that's been a whirlwind tour around the xLights source code. It takes a long time to get really intimately familiar with it, but to be honest, making the odd change here and there is not that hard once you can get a build environment up and running. I'm happy to take questions. I'm also happy to spend more time, and if people want me to do changes or bugs in Zoom one night, I'm happy to do that as well.
Definitely
So questions.
Any questions? Somebody's got to have a question.
I would, but I'm not intelligent enough to say it, so.
Has there been any look at integrating with the twinkly lights? I tried to go to the twinkly people and try to urge them to come into xLights, but I don't know if it's possible to go the other direction.
So Twinkly, to be honest, without a set of Twinkly lights, I have no idea what their protocols are, etc. We add protocols. We're an open source project. We try to be as agnostic as we can reasonably be. We've added support for a whole bunch of controller vendors over time. The project does somewhat support itself with some sponsorship, and so you've seen the Boscoyo and the Gilbert Engineering who both make generous donations to the project to include their models in the program, which we really appreciate their support. But in other circumstances, we add support because for the controllers, etc., and we've added those for all controller vendors without any ask for support, just because we tried to make things as simple to use for people as we can, and it made sense. Whereas the control of the Coro vendors always had the option of making their files available offline. It was more a matter of convenience having it in xLights.
All right, do we have any more questions?
Sure, I'll ask. Let's say we go into xLights and we try changing something and we break at it because we didn't really know what we were doing. What happens then?
So a couple of things. So first of all, you can't change xLights in a way that will impact on anyone else when you're tinkering with it. But when you've made your change and you're happy with it, you will do a pull request where you basically post your change to the xLights site. That change has to then get accepted by someone. Now, we would typically review your change at least superficially to see whether the change looks reasonable. Now, the more you work with xLights, the easier it is to get your changes included. People have a tendency to, we just accept changes from a whole bunch of people. There's a bunch of people who can directly commit to the repository, and then there are others that can't, but we generally accept their changes pretty straightforwardly. But if you're a new developer, someone's going to look at your code, do a quick flick through it. They may challenge you on some things. Please don't be offended, but you will get challenged on things to say, have you considered, and what about this, and I'm worried about that, etc. And we would expect you to go away and look at those things. The code base can be quite brittle. If you touch certain things, there can be consequences that aren't immediately obvious. And one of the more experienced developers is more likely to see that and flag it and say, hey, a little worried about this. And look, we've had examples of that in the past. The other thing is we kind of expect you to clean up your own mess. So if your change gets included and it blows stuff up, we're going to expect you to come back in and clean it up. Nothing more frustrating than having to spend hours and hours cleaning up a mess as a result of a change. But, at the end of the day, we're interested in having software that's reliable, and we will do that. We will clean it up and make sure that the bugs are fixed. We may reverse your change. That's fairly rare, but every now and then a change has been reversed. I've reversed some of my changes where, after a while you suddenly realize that, hey, that was actually not such a great idea. And in fact, the first changes that I ever made to xLights introduced bugs that I only found a year and a half later. But it's hard when you get into a new code base. You're going to make mistakes. Automated testing. If you want to write the automated testing, knock yourself out. Introducing automated testing into legacy code is hard work. There is some automated testing built into xLights, but it's more code that gets uncommented out and run because we know that the code's really complex and it's a chance that it will break. But, investing in automated testing in a code base the size of xLights is a huge amount of work, and it delivers no immediately obvious end user value. And so it tends to just not get as much attention as it otherwise might. There is automated builds, however. The Linux build builds automatically on every check-in. I get an email if it fails. It has a tendency to fail for reasons which have got nothing to do with the code being checked in, which is a bit frustrating. We have tried automating the Windows build. I spent a bunch of time on it. Scott's recently spent a bunch of time on it as well. It's not quite there yet. I ran into a whole bunch of, there you go, Scott says it works. I ran into a bunch of issues with the old GCC builds, which were insurmountable, but the Visual Studio automated builds are a little bit easier to get going. And Scott says he's now got it largely working. So the builds help, but at the end of the day, most bugs aren't build bugs. Most bugs are logic bugs that cause issues in the code itself. Having the automated builds is useful though, because it means when someone changes it for one platform and breaks it for another platform, we get told about it pretty quickly. Although you'd be surprised how rarely that happens, given that, I only test it on Windows, but I break it on OS X very rarely. It happens, but not often. I guess we're out of time.
Yep, only a couple minutes left, so I guess we'll just wrap it up. So yeah, thank you, Keith. And of course, thank you to our sponsor, Boscoyo Studio. Just as a reminder for folks, in this room at 5 Eastern, 2 Pacific, or GMT -4, and do your own math.